Hi. So this next video is going to be about the surfacing operations that we're going to use to clear up the flat planes in the model and then start working into those rolled surfaces as well. So the first setup stage that we're going to be putting together is going to be using an operation type called Flatland, which is very, very good for clearing out large flat regions and keeping them nice and clean. So we'll go back into the machining environment and we will add a new setup stage, which we're going to name surfacing. And we are going to close this down and then add a new 3D entry flatland operation. Now, it automatically selects every flat region in the workpiece that we've got, and it's going to do its best to try and do all of that. However, it does, by default at the very least, decide to try and scrub down the entire block and also go over a lot of these curved surfaces, which is not something that we really want it to do. So we're going to go into, firstly we're going to set a different tool. We're going to set the 6mm tool that we were using before, because we want something fairly precise and small for this. And the next thing we're going to do is we're going to go into the job assignment and we are going to delete that current job assignment that it's got. Now, we're going to be breaking this into multiple sections and stages, just for the sake of being able to keep everything clean and tidy and try to forestall any major problems. So the first surface that I want us to do is just this one. And I'm going to go and set the 6th axis control before that trips us up. And then I'm going to generate the toolpath for this to see what it comes up with. Okay, and as we can see, it's basically just decided that's where it's going and that's it. So we're going to go into the axis map and we are no doubt going to come up with the same problem that we have done multiple times so far. We have got a lot of deflection around the 0° region for axis 6. So we'll wait for that to finish calculating, we'll build a new graph and update the toolpath accordingly, and we should get a nice cleaned up area in this green zone. So build the graph, update the map. Okay, now the next problem that we've got here is we want to define just this as the job zone. So we go back into the job assignments and we've got this face assigned, but ideally what we want is we want to set this as the exclusive job zone and that's it. So in order to achieve this, we're going to have to go around and we're going to have to select all of the outline curves here, which is kind of time intensive, but it's absolutely worth it because it saves any future problems with the with crossing over any borders that we don't want it to. So there are a couple of other methods we can use. We have the option of either just selecting this as the job zone, which may resolve the matter, but it still means that we've got this completely unasked for section here and here. Or we can instead define this entire region now in one go, but that can sometimes lead to unexpected results. So we'll try defining this job zone first because it's the quickest option. And we'll regenerate the toolpath accordingly, and it should maintain all of the axis mapping details that we had. Okay, so generally that's actually looking pretty positive. That keeps us clear of the bits that we don't want it to go over, and it generally stays within what we do want. So sometimes it's worth just double checking and trying these different things out, and in this case it's worked for us, which is nice. So what I'm going to do next is I'm also going to tell it I'd quite like it to machine this surface too. So if we give it that face as well, and we then regenerate the toolpath. Excellent. So we've got everything flattened out here, and that should be good. I'm going to leave the other sections for a secondary operation just to be safe. But for the moment, I'll just quickly double check the axis map since we have extended that toolpath quite significantly at this point. I don't think there's going to be any serious problems there. And of course, we've extended this toolpath section, but we've removed all the exterior ones, which is why this graph is now exceeding the bounds. So if we click on build graph again and then update toolpath, and we should have a nice, clean, readily simulatable flatland operation. So if we zoom out a little bit now, just straighten that up slightly and run, we should see now that that's coming up nice and clean and close to where we need it to be, which is perfect. So the next thing that we need to do now is we're going to duplicate this flatland operation, but we're going to change the faces that it's working on. So we'll delete this and we'll delete this, and we are going to define, we'll start with these faces for now, and probably these as well. So click on that as faces, and we'll see what it generates from there. Give it a second to work through. Okay, so this is where we start having the problems. So we don't want it to come anywhere near here. Okay, we want it to just stay within this region. Now, there are a couple of different methods we have for this. We can either use the surface edge lines that we've already got, or we can just draw a specific job zone surrounding this, which may end up being the more expedient option. Firstly, though, we're going to check the axis map just to try and straighten out a lot of these more aberrant sections, because, let's be honest, that's kind of weird, and we don't want weird in this. We want nice and predictable. Okay, break that calculation, build the graph, and no amount of remapping is going to change that. So if we now go into the top orientation instead, and we zoom in to where we want to be, and we'll turn off machine visibility for the moment, we can see that we have the problem here now, that this is going off completely off register for where we want it to be. So the easiest way to do this is to define our own work zone. So we're going to delete this, and we are going to use the tools here available to us to draw a specific working region that we want it to operate within. Okay, I'm going to tighten these points up slightly just so it stays inside of the engine casing itself, because we don't want it trying to flatten down the surrounding region if we can avoid it. And we're going to set that as the job zone. So let's try regenerating accordingly. Excellent. That's much more in line with what we're after. Don't particularly want it going off down here, so I'm probably going to set these faces as restriction zones. So if we grab these faces here, and set those as restrict zones, and then try this again. No, it doesn't like that. So instead, I'm just going to edit the available work zone that we've got. Okay, and we're going to try and keep that there. And we'll rerun this. Perfect. That's pretty close to what we're after. Again, I don't much like having this particular rib region covered, but again, we're going to be smoothing that over at a later stage anyway. So we can delete that exclusion zone. We can rerun this quickly. It'll only take a second. And now that we've got this working, we can do the same for this region as well. So we'll go back into the top orientation. Sorry, don't know why it flipped around like that. And we can, we first have to turn off check for plunges, because that, I think, is the cause of its complaint here. Oh, gouges. Interesting. We'll check that in a second. Actually, let's quickly simulate this now, see how it looks. So we're going to reset that node status, and we are going to run this as it is at the moment, which looks fine. We'll set the verify compare, and we'll see that this region's coming up perfectly clean compared to what we need. So I'm not sure where the gouge complaint is coming in from there, but I'm not seeing any that are notable. There's a couple of very, very small nicks, but only in very tiny regions. So going back to this now, if we turn off verify compare and go back into the machining environment, we can duplicate this, and we're going to change the parts that we want it to work on now. So I'm going to select this area now, and we're going to draw another work zone around here. Which should hopefully see this done fairly neatly quite quickly. So we select this, define it as our job zone, and we select these as our faces, and then generate the toolpath. That's looking pretty good so far. We'll go to the axis map just to triple check. Okay, and that is our flat landing process pretty much good to go. So if we run this simulation now as well, we'll see that that flat land process has come in nice and clean. So we have our three environments, sorry, our three flatland regions defined and good to go. That pretty much sums up the bulk of the flatland cleanup for the interior faces of this now. I'm going to split this particular setup stage into two videos because it gets quite long from here on out, because we need to do a lot of detailed selection for the next part, which is going to be dealing with all of the curved non-planar surfaces. So I shall see you in the next video.